Hi, you guys. So we are officially done with the Algebra 2 textbook in our class. So now what we have is, you're all going to pre-calc next year. So the teachers in pre-calc wrote out a list of things that they wanted the, incoming students to know. Things that are really important, things that like the past students haven't known or have forgotten. And so, what we're going to do is we're going to spend our last 2 weeks going through that. And we're going to make sure that we hit the topics that are most important for pre-calc. So, after we're done with this 2 weeks, I would still recommend that you keep these and look at them before school starts in August, because what's going to happen is these are the things that your teachers are going to expect you to just know already. And if you have these notes, this is like the review for you, then you'll be prepared and you won't have to ask that question like, how did you know that that side was 2? Or what's cosine again? You don't want to be asking those questions um, because it's just expected that you already know it. Okay? So today we're going to talk about just right triangles, just 30, 60, 90, and 45, 45, 90. Tomorrow we're going to talk a little bit about trig. So here we go. Special right triangles. I'm going to read some of these and then I'm going to do some problems from your homework so that it's like, help you out a little bit. So you'll need your homework paper. Well, I think that you printed out everything, so you're probably good. Okay, so special right triangles. We have two special right triangles that are important to us as we study trig. The 45, 45, 90 and the 30, 60, 90. So 45, 45, 90. Let's get that drawn. Okay. Here is how. Okay, I want to point out that these are all right triangles. They have to be. So my triangle will look like this. This is 45 and this is 45. And that means that since this is 45, they're the same size, which means that the sides are the same size. If the angle measures are the same, the side opposite the angle, those two would be the same. Then, if I did the Pythagorean theorem, x squared plus x squared equals c squared, what I would end up getting for the answer for this hypotenuse is it would be a value of x rad 2. Okay? So, that's the relationship between the sides of a 45, 45, 90. All right, so now I want to do, let's see. Let's do something from our worksheet. Oh, well, I'm sorry. So if you know the length of one of the legs, then the other leg is clearly the same. The length of the hypotenuse can be found by multiplying the length of one side by rad 2. If you know the length of the hypotenuse, then you must divide that length by rad 2. So if I know the hypotenuse is like 8, then I would have to do a little more work. So actually, let's do two of those kinds. I'm going to give you one where I know the length of the side. So right now, pull out this page, and I'm just going to be honest with you, like already, number one is not just like a basic easy one. So what I want to do, I guess, let's make it easier, right? So I want you to just make, so cross this out on your worksheet. I want you to just make number one, just the side of a 2. So now, if this is x, x, and x rad 2, then that means that you're going to have, this is 2, b is going to be 2, and a is going to be x. Well, we know that the side is 2, so it's going to be 2 rad 2. Okay? So that's if I know the length of the side. That's a really easy one. Okay? Let's do number 2, where I know the hypotenuse. So I know that the hypotenuse is 4. If you know the length of the hypotenuse, then you must divide that length by rad 2. So I know that this is the same x, and x rad 2. All right, so this is where some of you got confused during class. I actually remember this. If the length of this side is labeled as x rad 2, but it has a value of 4, then I'm going to say that x rad 2 equals 4. Okay? So that means that now I'm going to solve for these two sides. They're the same. Don't let this y throw you off. Like, I don't even like that. It shouldn't even be a y. But, so I'm supposed to divide by rad 2. Divide both sides by rad 2. Here we run into a problem because I'm rationalizing the denominator. I can't have a radical 2 in the denominator. Here's rationalizing the denominator. Multiply the fraction by both numerator and denominator by that denominator that I'm trying to get rid of. I can't have a square root in the denominator. So 4 rad 2 over rad 2, which is rad 4, that's just 2. Still not done, because look, I need to simplify. So I'm going to simplify 4. I can't touch the rad 2. You're just simplifying. Let me cover it up. You're just simplifying 4 over 2. 2 over 1, right? But we don't put a 1 in the denominator. So it's just going to be 2 rad 2. So that means that x and y are both the same size. They're this. And again, I'm really not a fan of it saying y. It could just be question mark. Would actually be really more helpful. So both of them are 2 rad 2. Okay? So that's 45, 45, 90 triangles. So 2 of them are already done on your homework. Okay? Then I'm going to do 30, 60, 90 triangles. 30, 60, 90s are a little bit more difficult. Okay, here we go. So on 30, 60, 90. The 90 degrees is in my corner. My smaller side is going to be my 30. The larger looking angle will be 60. So now, the shorter leg will be opposite the smallest angle. This short leg is opposite 30. That's x. Here, opposite the 30 degrees. Okay. And then the longer leg will be opposite the 60 degree angle. The longer leg is x rad 3. Will be opposite the 60. When you're finding the side lengths, oh, they didn't talk about the 90. Anyways, the side opposite the 90 degrees will be double the smallest, 2x. Okay, I hope this is all ringing a bell. Now, this is all stuff that I can go through little bit by little bit. So if you know the length of the short leg, okay, let's find one where I know the length of the short leg. Here, number 8. The length of the hypotenuse can be found by multiplying the short leg by 2. So if I know the length of the short leg, go to number 8. Okay, the length of the short leg is 2. Please remember that this one is 2x, and this is x rad 3. Okay, get in there and focus. Okay, so opposite 30 is 2. U is the side opposite 90. That's double x. Well, this is x. So I'm going to say that u, the hypotenuse, is 2x, but x is 2 because it's opposite 30. So I'm going to say that it's 2 times 2, 4. Then the side opposite 60, it's not filled in, but we know because 90 plus 30 plus 60 makes 180. The side opposite 60 is x rad 3. Well, x is 2. So v is going to be 2 rad 3. Okay? All right, so that's number 8. Let's see. If I know the length of the hypotenuse, then you must divide that length by 2 to find the short leg. Number 7. Okay. This is 30. This is really what we call x, 2x, x rad 3, right? So the hypotenuse is 16. That's the 2x, which means that the shorter side right here is going to be 8. So y equals 8. I know that it says y. Again, I told you I'm not a big fan of this y. They're trying to make you think so that you're not stuck on, oh, x. You can think of it different. What if it were m? What if it were r? What if anything? It can be anything, okay? They just chose to label it x and y. So y is 8, but that's really like my, the number, the side that I go off of to find all the other sides. My hypotenuse was 16. So that means that my opposite 60-degree side is going to be x rad 3. Well, I know that the side that x is 8. So this is going to be 8 rad 3. And they chose to call this side x. Oh, you can't even see it. Why didn't you tell me you couldn't see it on the board? Just kidding. All right, I was zoomed in so much that... Okay, sorry about that. All right, so catch up because you obviously couldn't see a lot. Okay, there is more on the back side, but I wanted to go back to this. If you know the length of the longer leg, then you must divide that by rad 3. Okay, so I'm going to have to go to the back side for this. The side opposite 60. Here it is, 11. Go to number 11. And actually, it's the only one on the page like it. So if I know the side 60, remember this side is x rad 3. Here's my 30. The side opposite 30 is my x. This is my 2x, opposite 90. Remember? Okay. So the side opposite 60, I would have to divide by rad 3. 5 rad 3. But if this is x rad 3, then obviously the rad 3s are just going to cancel. So that means that the shortest side is 5. X rad 3 equals 5 rad 3. If you really want to see the math, I'm going to divide by rad 3 to get isolating x. Right? Can't I do that? Remember that? Okay. But they didn't call their x, they called it y, the side opposite 30. So I'm going to say opposite 30. Okay. Opposite 30 is 5. Now I need to figure out my hypotenuse. My hypotenuse is double the shortest side. Well, the shortest side is 5. What's 5 double? So that's just 10, right? They call it x. All right? So there's a lot going on there. Do not let the variables confuse you. If you don't like the x and the y, then just cross them out and just write down what I've done. The hypotenuse is this. The side opposite, the shortest side is 5. That's going to be a lot easier on your brain, okay? But keep in mind that this is Algebra 2, and next year's pre-calculus, you're going to see sides opposite that have these weird variables, okay? All right, the rest of your homework is going to be, because we're only doing the front side today, and tomorrow we're going to talk about trigonometry, sine, cosine, tangent. So the rest of your homework is going to be number 4, number 6, number 9, 12, 13, 16, 17. How easy, you guys. So I'll post the answers to this tomorrow when we do day 2. It'll be in the Google Classroom post. Again, reach out to me. People aren't really showing up to my Zoom sessions, so just reach out to me individually. I've literally sat in Zoom sessions and nobody comes. So I don't know. You guys need to email me personally, and absolutely we can set up a private, like if you want to just like go over something and you want to hear my voice and you want to see my face, then let's do like a private Zoom. So we are done. And this is the end of day 1, 30, 60, 90 triangles and 45, 45, 90 triangles. All right, I'll talk to you tomorrow, guys.